Welcome to Edureka's session on Puppet. Before we start, just a quick word about myself. My name is Sriram and I have about 20 years experience in the IT industry. For the last 10 to 15 years, I have been working more in terms of project delivery, project management, software architecture, and large-scale enterprise architecture. And I have been working as a freelance consultant and architect and trainer for the last 2 years. I am associated with Edureka for the last 1 year, where I have helped them with the courses on Puppet, Jenkins, and DevOps generally. And this has stemmed from my interest in DevOps, having led large project teams across the world. I've been interested in how to make a software delivery much faster, far more efficient, and therefore the interest in DevOps also grew, and therefore I've been involved with the DevOps for the last 6-7 years, and for the last 2 years as an instructor and a consultant in the DevOps field too. What is Puppet? What problems Puppet is solving out here? And we'll also be introducing you to a different concept here called infrastructure as code. What do we mean by infrastructure as code? Why this is important? We'll also be talking about the generic Puppet architecture itself, how Puppet is really working behind the scenes, and some common Puppet terminology which is going to be used periodically over the rest of the modules too. And finally, we'll get into the hands-on session where we talk about how to install Puppet itself from scratch. So we'll see, okay, this is a Puppet. How do we set up a Puppet master? How do we set up a slave? What is meant by a master and slave, etc. Now, to answer the question, why? What is Puppet? Why do we need Puppet 2? Imagine the work of a system administrator. The work of a system administrator is usually to install a server, which is fine, which is we call as provisioning, configuring them. Essentially, it's not just a question of taking Tomcat or Java and installing it, but also to configure this correctly. And this is a very important point, because this is where we end up spending a lot of time doing the configuration. If you were to do this, you'll see that much of the time that a system administrator spends, the installation or creation of a server is pretty much straightforward. Provisioning is a pretty straightforward activity. But configuring them and making sure that all of them are maintained in the correct state. Can you today tell me whether a particular server has the correct configuration file applied? Can you verify this? Okay. If we're now talking of 10 servers, 15 servers, probably makes it easier for us to just go manually examine it, but it's still a lot of time and effort to be done. And if I wanted to ever change the configuration in a controlled manner, and the key point is controlled manner, not an ad hoc one. So typically, your system administrator asks, okay, deploy XYZ application and change so-and-so property file there. Fantastic, great. 2 days later, the question is, can you revert it back to the state that it was 2 days back? Beautiful. And then we have no way of knowing what was the change that happened 2 days back. So that's where what we mean by a controlled manner change, which means that I should be able at any given point to be to roll back to any specific version or to apply a specific version on demand, not to have to spend my time searching for it. Now, these are certain tools, activities which Puppet can do. So now, typical to do that, if you were to do it on one node, it's a little hard to do this, right? Imagine the scale as it goes from 10 servers to 20 servers to 30 servers to 10,000 servers to thousands of servers. And you want to do this by hand? Be our guest. It's going to be very, 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 very difficult. So that's precisely the problem. Is not about just doing it for one machine. So if you have an infrastructure which has exactly one machine or two machines, you're good to go. There really is nothing much to be said about this. This works out just fine. It doesn't take much time. But when you start the scaling back into thousands of nodes, hundreds of nodes, thousands of nodes, you'll find that doing this by manually or even writing scripts to manage it is going to be a very, very tedious task to do. And it's essentially to alleviate these problems, Puppet came back. Essentially, Puppet is technically called as a configuration management tool. Now, even though it's called as a configuration management tool, It can also be used for provisioning, although we will not be covering that aspect of Puppet in this course. Just be aware that Puppet has expanded. It started off as a configuration management tool, which is meant for configuring and managing a server machine, but it could also be used completely for deploying a server too. So it can be also used for provisioning a server if you so require to. You can change and control the configuration right down to individual node levels. So which means that I can say on so and so node, this is a configuration that needs to be applied. I can do that at that level too. And importantly, if this is a very, very important portion, if you notice the behavior, the characteristics of servers, you will find that all of them are typically the steps to be done on most servers are almost similar. We use the word almost, which means that if I had to write the code once, it should be able to be working on node A, node B, node C. For example, let's just talk about a web server. What do you do on a web server? We typically install Apache or Tomcat or any other application server that we care to do and configure it back. The steps are going to be exactly the same. Maybe the content of the file may differ, but the steps to do that are exactly the same. So which means that I do not have to repeat the code for node A, then write node B, and then repeat the same code for node C too. So typically this is what we mean by defining nodes according to roles. So the roles usually can be whether you're a web server, whether it's a database server, and then more importantly, this is a thing. A web server on development environment may be different from a web server on a QA environment. So which means that we should be able to categorize a node specifically based on its role or its functionality or its stage or its environment. So either it's a dev or a QA or a staging or a production. So I can say a web server on development behaves slightly differently than a web server on a QA. Fantastic. Or the web server on the development and QA are exactly the same, only the property files change. Fantastic. Or you can say a QA and production are totally different servers too. That's also perfectly possible. Either way, that depends on your organization and your needs. But you can categorize servers and nodes, which means that the code which is used to write and configure, manage one particular node can be reused across various environments, across various roles too. So that's one thing. And then we always have the final problem. What happens if someone makes a change locally? Fantastic. Now, if you were to make a change locally, you should be able to roll back across saying that, okay, you made a temporary change. That's okay. But at this point, you made it once, I had to roll back to the original configuration. Now, would you do that manually? You wouldn't even know about whether it has been done. So typically, Puppet is also used for maintaining consistency across nodes. So which means that a change which is done locally will always be rolled back to the original configuration. So you can run it locally, but the next time onwards, the master will ensure that this is what I want in a node. This is what you will get. Your local changes are kind of overwritten with that. So Puppet supports over there. Now, Puppet is basically, so when we talk about Puppet, let me be very clear here. Puppet is a tool. So typically the term Puppet is used to denote a tool which is used for applying and managing system configurations all across the nodes, across all the nodes in your organization. It was developed by Puppet Labs about nearly a decade back, and yes, it allows you to do system automation, so which essentially means creation of a server, configuring of a server, undeploying of a server, etc. can all be done via Puppet scripts too. It has a specific language which is based off on Ruby. So typically, yes, a little bit of Ruby knowledge helps a long way in Puppet mastery. We don't really have to worry about this unless you're really looking at some very complex advanced examples. You probably are mostly insulated away from this one. But yes, the language or a specific language, domain specific language is basically loosely modeled on Ruby, and It does work on Linux, almost all Unix versions, Linux, Unix, Solaris, AX, BSD, Mac OS, and on Windows. The last statement is to be taken with a pinch of salt. Essentially, what it really means is that the servers usually run on Windows, on Linux boxes. The clients can run just about on any platform. To the best of my knowledge, as of today, we don't have a Puppet server on Windows. So people who want a Puppet server on Windows are sad, sorry. Okay, it isn't much. So it does work on everything, but a client, it can manage a Windows client, no problem. It can manage a Windows server. It can manage a Windows node, not a problem. But the server itself is not going to run there. Now, if you want to see the full list of all the platforms, the link is below here. So you can see under docspuppet.com, guides platform.html. So that should give you the complete list of all the supported platforms that Puppet runs on. Now, Puppet, this is the loose term Puppet. There are flavors and flavors of Puppet too. So while we say Puppet, the overall ecosystem is quite big. Okay, so what we are going to show you is the open source edition of Puppet in our classes. We are going to show you the open source edition of Puppet only. There is also a full-fledged Puppet Enterprise, which is commercial, which is you have to pay for the nodes, and this is breaking news. You should be able to get Puppet Enterprise free for up to 10 nodes. So you should be able, if you're managing less than 10 nodes, which unless you're a very small startup, usually that will not apply. But if you're a small startup and just trying to start off on Puppet, Puppet Enterprise is free for up to 10 nodes. As of yesterday, they just announced it, so that's fine. But other than that, you do have to pay per node. So you might have to talk to your local marketing representative for Puppet to find out the pricing details for Puppet. And yes, Puppet also has a graphical user interface, which is called Puppet Console, which is not going to be covered here. There are alternatives to using the Puppet Console, which is available only in the Puppet Enterprise Edition. You have the Puppet Dashboard, which is yet another graphical user face. We have tools like Foreman, which gives you a graphical user interface to Puppet 2. While we will not deal with all those components within Puppet, so when we say Puppet, just be aware that the term is used to represent the entire ecosystem of products. It's not just one single executable. Just be aware that there's a number of subsidiary tools within Puppet itself. It's so similar to what we have in Chef too. So we have a Chef, we have Chef DK, we have a Chef server, we have Chef client, we have the Chef console, we have Knife, we have Ojai, we have a number of tools. So typically the term Puppet is used to basically represent a collection of tools. Let me just put it that way, rather than saying it's a one tool. It's more of a collection of tools which are available out here for you to do this. Puppet can run, and this is a very, very important portion to do that. Now, typically, what you can do is Puppet can be used as a local command line tool on a single specific node itself. You can run that. You shouldn't have any problem. That will still run back for you. Or typically the usage is via a client-server relationship. So you can have a master and the clients basically communicate with the master to work with that. The server, and this is the commonest mode for operation of Puppet. So Puppet is basically, you can run it standalone too. Just like Chef. Chef can also be run without a need for a master. Salt can also be run without a master. Now, you can do that, but typically that's not the preferred way to do it. We typically use it via a client server thing. And typically what happens is we have one or more masters. Okay, you can have, when we talk about scaling Puppet infrastructure, we'll be talking about when should you start moving and having a different servers. When should you start having a single server? When will it make sense to have just one master? When does it make sense to have multiple masters? But typically what happens is, for simplicity purpose in the throughout, unless we explicitly mentioned, just be taking that we'll have one master, multiple nodes, and essentially the master applies certain configurations to the nodes. So the master has full information saying that this node should be configured in a specific manner. It should be configured in this particular way. These are the steps to be done. These are the software that should be installed. All that information is actually stored up on the master. When the client really talks back to the master sends off all this information back to the client. And this is exactly how the master, in a kind of way, this is exactly how Salt or Chef works. The mechanics are different, but the core concepts of your configuration management tools, whether it's Puppet, Salt, or Chef, work in identical manner. The master is the sole repository of information, and having that information, it starts pushing that one back out too. Who uses Puppet? A whole bunch. These are just some and some, quite a bit. Okay, Puppet is one of the leading tools out there. So when you're talking of configuration management tools, it's the leading market tool. So which means that typically, if you're looking for a job opportunity, you have a better chance of getting it with Puppet, simply because 70% of the configuration management tools today in the market are basically people are using Puppet too. So it's quite a huge market share too. So from a slide point of view, we can only show you some of these slides, some of the customers, but yes, any number of this are using Puppet, and it's one of the largest ones. So there's quite a bit of customers too here. Now, all that is great, but what is a problem that Puppet really solves? Now, typically, when a developer builds a particular code, and this is how the entire problem comes in from a DevOps point of view. A developer builds a code, they test it locally on the machine. This code somehow magically, the developers don't really care much about it, unfortunately, and that's the whole thing that DevOps tries to solve. What happens is that this application gets back and gets deployed on certain machine. And almost invariably, that code never works on a different machine. And the first thing that a developer ever says, it works just fine on this particular machine. Beautiful, fantastic, great. Now, at this point, the developer has made a change. He says it works perfectly fine. Other issues that the developer can say, I want so-and-so software at this particular version. Which version? 1.6.1.3. Whatever version you want to do. Now, this information never gets communicated back to the actually deploying that information. So typically, all that the SysOps does is to take that application, deploy it back without bothering with the dependencies. So which means that, so why did it not work? Who asked you to put so-and-so version of 1.5? We wanted 1.6. And the SysOps goes back and says, but where did you tell me that you needed 1.6? The developer says, I'm telling you now. So which means that the problem gets solved. At some point, finally, the SysOps gets down node 1.6, installs it back along with the dependency, and then finds node 1.6 has a dependency on XYZ at version 8. Fantastic. Now, when you does that, there's a lot of manual work to be done. There's a lot of changes to be happening. And that's one of the reasons why DevOps is all about making the developers and the SysOps communicate back to each other. So this is one of the biggest challenges. The developer writes a code. And what happens to the code? The developer doesn't care where it's deployed, how it's deployed. It works on my machine. All right, to tell you on this, and a whole bunch of other excuses, not really listed out here, but a lot of other excuses come in back and forth, which the SysOps gets back towards an end. And finally, when they get that information back, they end up solving the problem. But having solved the problem takes a lot of time to be done with that portion. Now, when they have done this, and when this is a thing that is happening out here, it has other things back here. Now, assuming that, okay, they managed to arrive at a consensus. On the other hand, when the developer comes back and says, look, I need XYZ of so-and-so version, assuming that the SysOps simply comes back and says, you know what, we are not going to support that version. We have a very specific reason why we are not going to support that version. We want it to be back to at 1.5. Now, what has happened? the deployment of your application which the person has done is going to get delayed. Finally, at some point or the other, what happens is one of them has to give way. Either the sysops changes the policy, updates that particular version, or the DevOps goes back to the previous version, redoes all their code to make it work on that particular version. Either which way, what happens at that point is very, very, very simple, simply put like this. It means that the delivery of your software is delayed, which means that your customer finally gets a pretty buggy software way behind its scheduled date. So which means that if you were supposed to release on July 1st, you probably are not going to release it before July 15th. Fantastic. Great. In the olden days, it probably didn't matter. A 2 weeks delay was part and parcel of almost every software project. In today's world, when your release cycle itself is 2 weeks, this is criminal. Literally, it really cuts down the productivity to a very, very great extent. Now, typically, when this happens out here, then essentially again, the sysops comes back with an excuse, the development comes with an excuse. There's always give and take between each one of them coming back. So someone says X, someone says Y. So finally, at the end of the day, it always gets resolved. Don't worry. It always gets resolved. The question is that how long did it take you to resolve that issue? 1 day, 1 hour, 1 minute, 5 minutes? How long did it take it? Now, let's say that the sysops decide, okay, we already have 1.6. Now, and we are now going to support 1.7. Now what happens is the sysop now has to go back, hunt around on the website, internet to figure out where is 1.7, download it, and to make sure that it's being downloaded from the correct source, bring it back to do the unzip, to all sort of a version. So the time that it takes is huge. This is not something that the sysop should really be doing. Instead, the sysop should be able to say, okay, you want 1.6? Fine. I'll give you 1.6. You want 1.7? I'll give you 1.7. So the next deployment is done. How long should the sysops take to do this? 1 minute? I mean, assuming that they're okay with that particular version. If they're not okay, that's a different story. That takes a little longer anyway. But to get you a new version from 1.6 to 1.7 to 1.8 or 1.9, or even if you say, hey, you know what, we decided to go back to 1.4. Fantastic. Bring it back to 1.4. How long should the sysops take to do it? It should not take them more than a minute or 2 minutes to do this change and be done. Done. Finish. All they have to say, use 1.6, use 1.4. Let the system handle it because you know where to fetch the file. So in such cases, this is exactly why the problem really comes in back here. Essentially, and this is where the biggest challenge comes back. Provisioning of a server is one of the biggest challenges. Deploying a server or an application to a server is a very big challenge. For people who have followed the Edureka Jenkins course also, you will know that creating an application is pretty much straightforward. How do I make sure that this application is deployed to, say, 50 servers? How do I make sure that it is on all 50 servers, it is working correctly? How do I make sure that it is configured correctly on all these 50 servers? Now, if you're talking of just 1 server, 2 servers, not a problem. But in real life, that's not what happens. We typically have what are known as load balancers. So we have in number of servers. We are saying, hey, you know what? We have 1 million users. So I need 100,000 servers to satisfy this. So you're taking the application, you're deployed. Now you're going to deploy this on 1,000 servers? Beautiful. If you're going to configure this by hand on 1,000 servers, good luck. And by the time you finish configuring the 1,000th server, you would have found that users have already started hitting the 900th server, 950th server, and they'll say that this behavior is inconsistent. So what happens is the time taken to do this deployment or to do this configuration is pretty significant. So what happens is at that point of time, okay, users are very, very liable to see inconsistent interfaces. And essentially, when that happens, the customers are not ever going to come back, or at least are going to have a negative feedback on what you are thinking. So they're going to say, hey, you know what? Maybe X doesn't know how to do their business. They don't even know how to deploy applications properly. Now, that kind of negativity, that kind of, it is called as negative goodwill. In fact, it's not a goodwill, it's call it as bad will. That translates into word of mouth, and once it translates into word of mouth, it affects your final day. Would you do further business with us? Probably not. And that's exactly where it happens. Now, essentially, when this happens too, we also have yet another problem coming in back here. Okay, so we have resolved the problem of deployment and configuration. How do I monitor these 7,000? How do I even know whether the deployment is going on time? Okay, I have written an automated script. Good for you. Fantastic. So you have written a script. Brilliant. Now, having written the script, you say, hey, you know what? I wrote a script. I don't have to do this manually. I can deploy and configure all via script. Fantastic. Beautiful. How long did it take you to deploy this on 1,000 servers? 1 day, 2 days, 1 week, 1 hour, half an hour, 10 minutes? How long did it take you to do this? And then when you say, yeah, the script it still deployed, it still did the configuration, so I'm not doing it manually. Great. So you have solved one problem. How long does that script take to run? Does it take 1 day, 2 days, 1 week, 1 hour, half an hour? How long? You do not know how long it takes. Now, typically, you might want the script itself to run within to deploy this to 1,000 servers within one specific thing. So in such a case, what we do at that point is essentially we need to monitor how long our scripts takes to run. Now, once again, you go back, you get your administrators, once again, you start writing your script to make sure that it is now giving you statistics on how long it takes to do, and then you start measuring. Is it running within 1 hour? Great. Is it running it within 2 hours? Great. Can it run it within half an hour? Beautiful. Great. Can it deploy to all 1,000 within 10 minutes? Fantastic. Now, if you don't get that, then what you need to do is we again had to revisit our script back to say, okay, for 100 nodes, it can deploy within 10 minutes. Beautiful. For 1,000 nodes, it is taking 2 hours. For 2,000 nodes, it's taking 1 day. So once again, you go back, revisit your scripts again to make sure that you are scaling up to that demand, on demand, 100, 200, 500. I should be able to deploy it like this. Not a problem. Now, typically, as this keeps growing back out here, it will start, even if you start writing your own custom scripts. Now, what you can do at this point is essentially what it will show you is that, yes, it will now show you that it becomes harder and harder to maintain custom scripts over the place. Now, because you are having the custom scripts going back, it becomes more time consuming, more error prone. Sooner or later, half the time you will be ending up writing and modifying your scripts rather than actually doing the server monitoring and deployment too. Now, given all of this, rather than writing custom scripts back for you, this is essentially the challenge that Puppet or any other tool tries to solve. It allows you to provision servers as quickly as possible on demand. It allows you to deploy applications on demand. It allows you to have custom configurations at the specific node things. It allows you to monitor how much or how your applications are being deployed and what things. It allows you to quickly revisit these metrics to allow you to scale to beyond larger numbers, and it also does this in a secure manner. You could do all of this, and let me be very, very blunt too. If you have enough time on your hand, a very, very experienced shell script person should be able to knock off the script. But maintaining the script, maintaining it for scale, maintaining it for security, maintaining it for monitoring, maintaining it for logs, and to be able to support anything on demand without modifying the code again. It's a very, 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 very tedious and time-consuming task by itself. So if you have the money to burn on it, great. Otherwise, just go in for any of the existing tools like Puppet, Chef, Salt, Ansible, and you're good to go with it. So that's the reason and the challenges that this really comes back to. Now, we did talk about why we want to mention what is configuration as a thing, infrastructure as a code. Typically, this is one of the bigger challenges of the DevOps world too. To a developer, when they make a code application change, they are expected to test their applications before actually deploying it back to a server. So they are expected to do a testing. Now, for a system administrator, when they make changes to your configuration files, the question is, do you test whether this change is correct or not? No, we change it. We assume that things will work fine. And if things don't work fine, we will revert back to the change. Fantastic. So you have reverted back the change. Beautiful. How do you know whether you have reverted back to the correct change? You have a configuration file which is 300 lines big. What changes did you make? So typically, the way we do is we put configuration file thing that this was the change made by Sriram on 29th June 2016. And then look around and then we realized we forgot to add one comment. We forgot one line, okay, where we forgot to add this kind of a comment. So at this point, we do not know which version is to be kept. So typically we do expect system or administrators to also keep a track or to use version control for your configuration file. Now, this has certain important implications, which is essentially means that at any given point of time, I should be able to roll back to a specific version whenever required. So tomorrow, if you say that I want this particular version to be installed, I can do this. If I want to make a change, I can make a change. I can do the testing, rough testing back out here. And if everything works out fine, then and only then deploy it for actual rollout to production servers. So I can even have a testing server. So even the infrastructure changes itself has to be tested back here. Now, typically, this also means at this point, what we are saying is that, hey, you know what? We need this to be done in that portion. Now, this ability to keep a track of all your configuration changes, to think of configuration itself as a code, which means that any configuration has to be maintained baseline. It should be able, any action should be expressed as code and it should be tested. I should be able to bring back any version and deploy any version of my infrastructure at any point is out here. So typically, this also gives a lot of benefits to the organizations where we can also have who did what changes. So tomorrow you have an audit history saying which of the systems did what. When did they make the change? When was it rolled out? Who did this roll out? When was this application deployed? The full history is available to the organization for further action down the line. Any given point, if I wanted to, this has been tested, done. So if I wanted another node to be set up in the same way, I don't even have to do that. All I had to specify is this node uses this particular code base and I'm done. I don't have to do anything specific for it. So which means that I can reproduce the setup any given point of time. So tomorrow, if I wanted to deploy Tomcat on machine A, well, I have written the configuration, it has been tested, it works out just perfectly fine. And if it has worked out just fine, you know what I'm going to do? I'm going to deploy it on this particular node. Okay, node 1 has been done. Second time onwards, if node 2 also wanted Tomcat to be done, I don't even need to rerun the steps back again. Hey, it works on 1, all things being equal and same. If 2 environments are exactly the same, then the action, the programs which will run on machine A will work exactly with the same behavior on machine B too, and machine C, machine D, machine E. As long as the environments are the same, they will work just fine. I don't have to retest it back again. So which means, you know what? My testing time, the uncertainty which is available in the market about whether this application deployment really went fine, not fine, all that uncertainty is taken care of by my reproducible setups too, which essentially means that do it for once, I can scale it up for A, B, C, D to hundreds, thousands, not a problem. I can scale it just fast. Once, right once, repeat it for any number of times. And it also means that on all the servers, your Tomcat, as an example, is going to be configured exactly the same way. Of course, we still have specific node-specific setups, but apart from that, everything else remains exactly the same. If I didn't have a node-specific information, on all 100 machines, they are going to be coherent, same way, set up in the same location. Which means that on every certain machine, for example, if I chose to install it on directory A, it is going to be installed on directory A for all the machines. End of story. So tomorrow you don't have to go around and say, okay, Tomcat here is on XYZ directory. On this machine, where have you installed it? Yeah, you know, you are doing it manual installation. You are free to install it any way you want to. But with an automated installation, they all are consistent across. So which means that these environments can also you can also have what we call as aligned environments, which means that I can have one set of setup for development, one setup for test, one set for QA, one set for production. Once done, they are consistent across the environments. They don't change at all. Is Puppet the only alternative? Nope. We have Chef, we have Salt, we have Ansible, and yes, just be aware that Edureka has courses on all of this. So depending on how you want to do it, we would strongly recommend that you go into Edureka's courses for Chef, Salt, and Ansible too, because they have it in detail too, where we talk about each one. So typically, one tool fits all solution doesn't work. We might end up having multiple tools in an organization. In such cases, going through these courses will also be of benefit to you. Now, we did mention this before. At this point, the environment, or what we call as Puppet, some of the terminologies and the things which are there. By default, when we talk about Puppet Labs is a company behind Puppet. So when we talk about Puppet Labs, we are talking about the company that's behind Puppet. It did start off, so when we talk of the term Puppet itself, we said it's a whole set of tools, but just be aware that these represent the open source version of Puppet. If we are explicitly mentioning Puppet Enterprise, or in short form, it is usually referred to as PE. Puppet Enterprise. Puppet Enterprise is a commercial edition of Puppet. It comes with a lot of other things too. Typically, it comes with a web console, which Puppet open source does not really come back with. And essentially, it also comes with other services like orchestrator and coordinator services. And it the same thing can be done with the Puppet open source version. It's just a little more harder way to get it done. Only thing is the Puppet Enterprise is limited, as we said. You do have to pay money for it. For up to 10 nodes, as we said, it's free. Beyond 10 nodes, you will have to pay money for it. Refer back to that one. The key point of everything comes back under the Puppet documentation, which is on docs.puppet.com. Docs.puppet.com has a complete list of all the documentation which is available. So in a hands-on session, we'll be talking to where this documentation is available, and it depends. Again, be careful. It's not the best organized documentation. So you'll have to correctly choose your particular version. For example, you have to refer to Puppet 3.x, 3.8, 3.7, and be aware of this. There are subtle differences between each version of Puppet. We'll be talking about these differences back over here. Specifically between Puppet 3, Puppet 4, and Puppet 2, there are quite a bit of differences coming back. We don't use Puppet 1, it's dead and gone, and it's like old-time archival history. But yes, the current ones would be about 3.8 on the officials on the 3 branch and 4 on the actual version 2. We also have a large number of pre-existing code in Puppet, and this is one of the strongest point of Puppet, which essentially means that, as we said, hey, you know what? It makes sense if you are willing to learn Ruby and want to become a big guru on that. Yes, perfectly fine, learn a thing. But other than that, to get quickly started, you don't even have to write code. You can actually download pre-existing code which is available. These code are available in what we call in form of Puppet modules. Now there are 2 sites which are there. One is called module, forge.puppet.com. Will have you the whole list of all the modules which are there. If you're interested in seeing how the modules themselves are written, or if you want to see the code behind the module, hey, you know what? You just want to learn the language. You just want to know what's going on in the background. So you want to know that. The entire source for those modules are also usually found under GitHub too. So the starting point would be a Forge module Puppet, and from within there, inside GitHub, they usually have a link back to GitHub, which also gives you the source code for your those modules too. So if you want to know how those modules are written, what it contains, etc., including the documentation for those modules. And this is one important thing. When we talk of Puppet documentation, be aware that it contains only the documentation for core Puppet. It does not contain the documentation for the modules. The documentation for the modules are usually found under the GitHub sites for the particular modules or within module Forge itself. So that is purely as, since it's an individual contribution, the documents may or may not be up to date. So you, therefore, invariably, sooner or later, you will come back to the community, which is all your forums, user groups, etc., where people come back and say, you told me in the documentation that this is X, X should be written, X does not work. To which somebody will come back and say, yep, this is an issue. This has been resolved by this in this particular version, or here is a workaround. So invariably, unfortunately, it's still evolving. Those documents are there. A whole bunch of tools are available inside Puppet 2. We will be collecting a few of them too, okay? And we'll be looking not on all of them, but typically the one of the tools that we'll be looking at is in the background, we will be using a tool called Factor. Now, what Factor really does is essentially you need to write certain amount of code, okay, depending on the operating system in which the node is applicable. So you may not want to run this code. You might say that if the platform is Windows, don't do this, because we know that Windows doesn't support it. If the platform is Ubuntu, do this. If the platform is Red Hat, do this. You might want to write code based on that particular portion. Now, how does Puppet know to get that information from? What Puppet really does in the background, your client or etc., they basically use a tool called Factor. Even though you are not running this directly, I mean, you can still see that running directly, but what you will actually see is that this is actually used by the client or the master in the background itself to collect information about the system. Example of system level variables, okay, would be, what is the node IP address? Fantastic. What is the interface, network card interfaces that it supports? What is the operating system? How much disk is free? How much disk is used? How much memory does this thing have? What operating system is it? Which version is it? Is 64-bit, 32-bit? How much? Who are the users? Is a user existing? what are the groups which are available. All kind of information related to the machine or on a per node information is essentially available via Factor. That Factor basically collects all this data out here. Now, how does this data get stored, or how do you want to use this data is purely up to the rest of those portions. When we talk about the code, we'll see how those variables are used, and typically we will also be using a tool called Hera. Hera is basically a tool which basically does nothing but have a mapping. This is my key, this is my value. This is my data, this is the value. This is the data key, this is the value. For example, you may have something called operating system. The value of operating system is Linux. Then you may have memory free as another thing. So you can say memory free equals to this much. So in essence, you are basically saying this is my data key, this is my value. Data key, data value, data key, data value. So which essentially means that given this ordering, okay, of value, Hera can manage it very easily and say that given this, find me the value associated for operating system. What is the value of operating system? So you can just say Hera operating system. It should show you that value back out here. Now, by default, okay, Puppet runs happily, nicely, not a problem, etc. But the more important portion of this is to use mcollective. Mcollective is where the true power of Puppet really starts coming back here. What you do with mcollective is essentially you can use it to run specific actions against specific nodes. So you can just say, first run this on these 10 nodes. Hey, configure first these 10 nodes. Then having configured these 10 nodes, then configure these 5 nodes. Otherwise, there's no other way for you to actually do this kind of things. Okay, it's very hard. Now, mcollective is a very powerful framework, which is again mostly a command line driven framework, which allows you to control and see which tool, which node should be done, where the rule should be applied, on which nodes it should be done, how it should be done, which node should be done, followed by what data comes back from there, how to pass the data back to the second set of things. Oh, you can do a whole bunch of things with mcollective. And this is where we'll be seeing that when we talk about fourth one, when we talk about complex architectures, we'll be looking at partially in mcollective. We'll start work on mcollective also and telling you how it is being done. Data generated is usually stored. You don't want to throw it away. You want to retain it for a larger period of time. So we do not cover PuppetDB in the rest of this course, but just be aware that if you want to store the data for future use or for referencing or reporting for archival purposes, for etc., you would be using PuppetDB itself. So at the back end, either by default it is PostgreSQL. If you want to, you can change it to MySQL also, and then say, look, this is where I will store my specific data to. So you can just specify all the data, your logs, your collection, your run statistics, how many times it was done, etc. All those data can be stored for future. Like, think of it as a persistent data store for it. Okay. Now, we are not talking of what is a node classifier. We'll come back to that topic of what is the ENC or external node classifier, etc. You have a number of front ends. Okay. As we were recollecting, so people have asked this question about what mcollective is all about. mcollective is a command line tool which essentially, and a framework which allows you to do complex orchestration of actions. By default, when you apply a Puppet rule, it has to match against all specific nodes. So it can be pretty much inefficient, and sequencing the actions can be a little problematic. So typically, mcollective allows you to sequence the activities in a way where you can say that first do this on node A to B, followed by node C to D, followed by E to F. So you can specify rules and say this is how it should be done. So in kind of a way, think of it as a very powerful tool for doing orchestration of the sequences on different nodes too. Now, we are not covering what an external node classifier is within the session itself, but to just give you an idea of what it all means is that it's very, very difficult for people to work with a command line tool all the time. We do recognize a need and say that this is a very, very, very difficult one, and essentially it's something that is harder to do. So typically what we try to do is we try to use a web interface as much as possible, specifically for reports too, where it becomes easier to see what it was doing and not doing out here. One of the most popular web consoles, which we are not showing out here, happens to be your Puppet console, which is part of your Puppet Enterprise itself. So the Puppet Enterprise has a full-fledged console. So you can access it, Puppet, through the browser itself. And from the browser, it becomes easier for you to manage nodes. So you can add nodes, delete nodes, deactivate nodes, etc. The same thing you could do with the Foreman, which is yet another third-party provisioning tool, and you can also do it with the Puppet dashboard itself, so which again becomes a front end for you, and which allows you to manage nodes. And this is a very important, and that's where we would talk about an external node classifier. So typically what you can do is you can start specifically managing nodes via the front ends too. So these are tools which give. So when you're taking it out from the core Puppet and throwing it into a web interface, and from the web interface you're able to manage node, user, permissions, etc. Those tools become known as external node classifiers to some extent. They allow you to do a great deal of node management. Otherwise, it becomes a little tedious to do that by hand or by a script, etc. too. And if you're ever building code, you are writing your own code and managing your own code, we strongly recommend using an IDE called Gepetto, which is similar for people who are coming from a Java background. This is almost equivalent to Eclipse. It's something based on Eclipse itself. So it allows you, it is specifically geared for allowing you to write Puppet specific code, so which means that it has a specific Puppet level components which allow you to validate your Puppet code, make sure that everything is running fine, and before you actually push it, it can allow you to integrate with GitHub, etc. So you can push your code back out there, so you can keep a track of all your code, Puppet code that you have written to manage your infrastructure. So we strongly suggest that, yeah, you could do it with a Notepad too, if you are interested, but we strongly suggest that you go ahead and use Gepetto itself. Now, Gepetto allows you that kind of freedom and the flexibility which a Notepad doesn't normally give. There's a certain amount of software which are around there. So for example, Factor, we will typically not be using directly. Just be aware it is around here. Yes, we do use a Ruby. So Ruby is required and to be installed on your things. And it does, your installer sometimes will install Ruby for you. There is also, unfortunately, each version of Puppet also is very, very specific on, or depends on specific versions of Ruby. So it is not enough if you say Ruby 1.9. You have to say 1.9.3. The specific version on which it depends, please refer to the Puppet official Puppet documentation, which says for this version of Puppet, this is a supported version of Ruby. But this version of Ruby, this is it. So if you are planning to install Puppet anyway, and you already have Ruby installed, just be aware that you might have to play around with the Ruby itself. So even though Ruby is a software related to Puppet, just be aware that the version matters. Refer to the official documentation. If the versions do not match, you might have to play around, uninstall, and put the correct version back to. So just more in terms of your things. Why do we need this? Why do we even talk about Puppet as a code? Hey, we were talking about deploying servers. Why do we need to even talk about it as a code? Unfortunately, without thinking good, bad, or ugly, okay, the software world has gotten evolved into something which is a very more, a little disciplined and a structured way of doing things. Like you start with your requirements right down to testing, especially testing out here. So which also means that in today's world, IT development has gone into the agile world. So which means that they can make a change very, very rapidly. So today, if you talk about agile has been so widely adopted. So the development team is almost say 3 cycles, 4 cycles ahead of the SysOps team today. In the sense that we are 4 releases ahead, we are 5 releases ahead, we are 6 releases ahead. SysOps is still working on Tomcat 1 because there's still that problem of taking those applications, deploying it, and deploying it rapidly. In the olden days, when you had projects which are 6 months old, 1 year old, 2 years old project, deployment happens maybe once a quarter, maybe once in 6 months, or maybe at the time of release, which is at the end of 2 years. So SysOps was a relatively relaxed environment. Unfortunately, today's world, you cannot continue in the same way of thinking. Just as the development team rapidly to making changes, you need to be responding fast enough to do the deployment as fast as possible. Whether you like it or not, there are certain good practices from Agile which have made it think. One, versioning of code. In the olden days, SysOps would just make changes left, right, and center to infrastructure files. Nobody even had a clue, and it all depended on one person or two persons, and if the two, nobody even knew where the files were, what the files were meant. So it became very difficult to follow what changes to be done, how to roll back a change became very, very difficult. Now, essentially, just like we had done it for development, this was also done via infrastructure automation. So just the same way as you have noticed Edureka's Jenkins classes, you would see that code became very easy. You make a code, build a code, the moment the code gets changed, it gets compiled, it gets tested. Importantly, it gets tested, and if you want to, I can deploy that application anywhere. Now, when you start talking of that kind of rapidity coming in back here, what changes needs to be done? Now, at every single point, the development team may require a change to your configuration file. Fantastic. So which means that essentially your development process automatically, when you're talking of deployment, takes those change configuration file and put it back automatically. This should be done in parallel with that. So when the development team is making the changes, they have made the code changes, they communicate back to the DevOps team saying that, look, this is the configuration file that needs to get changed. The moment they get to saying this is the configuration file that needs to get changed, the change is done, verified, tested. The moment the development team is ready for deployment, this configuration file is also ready for deployment. Straight away take it and be deployed. So that's how it needs to be done. Previously, what happened was we will wait only after the development team is done before we start writing a configuration file. That doesn't quite work when we talk of infrastructure as code. If you talk of on those lines, infrastructure as a code has no meaning. Essentially, we are saying both teams is basically coding at the same time. Okay, maybe the SysOps team has finished testing the configuration file faster than the development team. That's fine. But at least it's ready. This is a concept called a continuous delivery. We are ready for delivery and deployment at any point of time. Today I'm ready. Tomorrow it's ready. And if they roll back, not a problem. I may or may not deploy that application, or I might decide to use a different version of the configuration. But ultimately, it is consistent, repeatable thing that, hey, for this thing, this is my thing. Apply across 1 node, 10 node, 100 node, 500 node. Just do it repeatedly, consistently out here. Now, this is where it has become as a very big thing. Okay, so essentially, okay, this is one of the biggest things that we have talked about. This is the same point. Both development and ops team work together. So, which essentially means saying that, hey, you know what? I need Tomcat 7.1. The development teams tell you beforehand, not after the end when they're done after 2 weeks. Okay, it is working together. That's a key point of this entire infrastructure as a code practice. Essentially, you need the feedback from the developer. So the development and the SysOps team works not at the end of the cycle. Right from the day the development team starts working, the SysOps team is also working. What infrastructure do you want? Tell me now. Don't tell me 2 weeks down the line. You want a Tomcat 7? Fantastic. I have got my Tomcat 7. Now, we have kept it ready. We have tested it out. We have made sure that, you know what, our deployment of Tomcat 7.1 works fine. After that, your application, does it work on the Tomcat 7.1? Maybe, may not be. I don't care. Okay. Probably, for all you know, they may not work. But from the sysops point of view, hey, you know what? We wanted 7.1, we have 7.1 ready. Are you ready with your development? Fantastic. Do you want a server to be set up with 7.1? Click on the button, done. No time, finished. It's all done. And that's the idea of doing that back here. The idea there is to say that at any given point of time, if you even say, look, we no longer support 7.1, we are rolling back to 7.0 for whatever reason. Maybe the application has too many bugs on 7.1. Maybe 7.1 has not even been adopted in the market. Maybe the customer changed his mind and said 7.1, let's go back to 7.0. Fair enough. Can I go back to 7.0? Can I go back to the configuration which is 7.0? I have my version control. So you know what? I had a configuration file which said at 7.1. You want to go back to 7.0? Go back, take the 7.0 version, put it back, deploy, finish. Not a problem, it'll still run. So that is where the whole idea of infrastructure as a code comes in. So the benefit of infrastructure as a code simply means that you have version controls. You have continuous testing of your infrastructure. You have continuous integration that at any given point of time, you're there. You're continuously ready for delivery to the person. It also helps you, once you have started thinking of your infrastructure as a code, then principles of design also come into picture. Is this the best way to model my infrastructure? How much lines of code have I written for my infrastructure? 1,000 lines? Can I do it in 10 lines? Can I do it in 20 lines? Can I do it in 30 lines? Wow, okay. Can I do it in 100 lines? Now, you can write code in 100 lines, you can write code in 10 lines, you can write code in 1,000 lines too. Now, then there's a balance coming in back. What is the balance? 1,000 lines is simply not acceptable. 10 lines, nobody is going to even understand. Once a person who wrote it has left it, nobody is even going to understand what that 10 lines. 100 lines, while it is not as efficient as a 10 lines version, is at least has a benefit of being understandable, maintainable, things which are of importance to the organization. The organization wants your code to be maintainable. If nobody understands the code that Sridham has written, there's no point in Sridham writing the code. Sridham can write the code, and then finally tomorrow if Sridham leaves a company, who's going to maintain the code? Everyone looks at the code and stays blank. Okay. So that's something which is there. So it's a kind of a balance. And that balance, how you do it for performance in terms, or if you want performance as a bigger goal, then you can talk of that. So it's continuously refactoring. Then you look at it and they say, hey, you know what? We have 10 servers. Do we really need 10 servers? Can they all be merged in one? You know what? I do have a 32 GB RAM machine. Why do I need a separate web server? Why do I need a separate DB server? Why do I need a separate application server? For development, all of them can be on the same server. Can it be done? So you start thinking on those lines as a code base, and once it starts looking at a code, because all of this, be aware, in Puppet, Chef, Salt, you are writing you're declaring, you're not actually writing a code in the traditional world. You are basically defining and declaring your infrastructure in a series of executable statements, which Puppet, Chef, or Salt can convert and deploy. That's it. Think of it as near English language, which is basically code. Okay, it's not code as a Java code. Okay, there are sometimes when it's not. Okay, think of it only as a declarative one. But once this has been done, essentially, then you are on the path of thinking of a puppet as a puppet master. Okay, so once you start thinking, yes, all my configuration is code. These are the benefits, and you buy into those benefits, then you are halfway into becoming a puppet master too. Congratulations. Now, all that is a basic stuff out here. Now, what you can do out here is then see the overall architecture, how this really works behind that. Now, you can have one or more master server. So it doesn't have to be just one server too. It can be multiple servers. Now, the open source platform doesn't really have good reporting or anything else. Yes, it does have the Puppet dashboard. If and very frankly, you're better off not using it that way. You can use Foreman itself as a better tool for that. The open source version. The enterprise edition, you have lovely, lovely console, okay? And it does require a minimum of 16 8GB RAM machine. It does require minimum of 100 GB disk space for the installation. Forget actual things. Okay, you need 100 GB just for the installation, and yes, it does require at least 16 GB RAM. 8 GB is sufficient. 4 GB is sufficient. In practice, 8 to 16 GB is required for that machine to run. Free memory. We are not talking about available memory only. We are saying we are not talking about the total RAM is 8 GB, of which 4 GB is used by other application. No. So the enterprise edition has a different together. Now, in between, when we start, and the master server basically controls all the content to be pushed to the agents. The agents are the machines on which the client code is going to actually run. Okay, literally. So for example, I may have machine A, machine B, machine C. So you have agents running on machine A, machine B, machine C. You don't have an agent running on the master itself. You could do it. You could have the agent run on the master too if you so want to, but we typically don't do it that way. We keep the master separate, all the agents separately out here. Now, what this really means is that the agent really runs, whether that agent is running on a physical box, on a virtual machine, or on the cloud, we don't care. The agent can run just about anywhere here. Even the master, for that matter, can run on a virtual machine too, or on a cloud. Not a problem. You can still run it out here. Essentially, all it does, the agent and the master communicate back and forth, and when the agent finishes its run, it sends its data back, called reporting data back to your master server. Now, when we talk in the last section, when we talk about scaling the Puppet, we'll see that how the same simple architecture that we're seeing out here is going to be expanded and changed drastically to the point where you will not even recognize that this is the same thing. For example, on what we are showing out here, we are saying the reporting happens to be on the same machine. We are saying the administration and security also happens to be on the same machine as master. In practice, as the number of nodes increases and the number of tasks increases, you will find that your master server is split up into 1, 2, 3, where one of them is basically used only for serving the content for the nodes. Okay, that's it. It's only used as a content server. Then you have one which is used only for reporting. You have one specifically only for admin and security. So even though for simplicity we have shown a master server and said within a master server, all these are the components, we can say that in practice, take reporting separate, take security separate, take content separate. Hey, you know what? We don't want one machine to do all the job. Why should it? Let this do only this, let this do only this, let this do exactly only this portion. Now, all of this is given back out here, and this is a basic architecture out here. Typically, how this really works out here is the fact that when a client, a node, establishes a connection, okay, essentially all it does out here, it sends certain information about itself to the Puppet master. So it comes back here. And then once this has got that information back here, the Puppet master then sends what is known as a catalog back to the node, saying that how should the node be configured. So you are machine A, beautiful. Now, if you are machine A, these are the information that I have about you. These are the tasks that you need to do. You need to configure Tomcat. You need to do Apache. This is the sequence of steps to be done. Here are the steps to be done. Notice that the master is not doing this on this agent. The master only sends a catalog back saying this is what you have to do out here. Now, what happens at this point when the node receives a compiled catalog. At this point, it executes the steps. Basically, it's a Ruby code, right? So essentially, it executes a Ruby code against each of these steps, doing step A, step B, step C, step D, step E, and then having done that information, sends that information back, the status back to the master, which is basically a reporting back. That completes the cycle. So once it has got the data, the Puppet master can actually configure and then either publish it on the dashboard itself, so which basically makes it back out here on the dashboard. So on the dashboard, if you have a dashboard or a web console or forward, you should be able to see the statistics running back and forth. Otherwise, if you so want to, you can also specify the collection, sending it back to any third-party tool. For example, you can send that to, for an example, to Logstash. And from Logstash, you can send it off to Elasticsearch. And from Elasticsearch, you can probably send it to a Kibana visualizer to show you the data in whatever format that you want. So either which way, so it's your call how you want to do it. Either you can use a web console or the foreman or dashboard, or you can use a ELK stack if your organization has already got a Elasticsearch, Logstash, and Kibana format. So that should also be perfectly possible for you to send it back across both ways, any which way this works. The flow is simply this. The client establishes a connection with the master, sends the information back to the master saying that this is who I am. So the master sends it back to the node saying that this is what you should do. This is what is done. Then once it is done, the report goes back to the master, and the master either collects the data, displays it, or forwards it back to any other third-party tool. This is the generic flow of the sequence of steps that is done for things. Essentially, if you look at it, when it does the connection back, and this is how it really starts working back here. Now, you can do Puppet console or any other data source, etc. out here. Now, typically, what you will be doing is, you can have any number of plugins. Essentially, all the agent really does is to run factor, get the factor information back, and tries to get some information for the node, classify it either from an ENC if that is there. And then once it has got it back, either from an ENC or not, it will come back, compile your catalog, and it will apply the catalog back out of here. Now, if it requires certain files or certain reports or certain resources, for example, you may say that, hey, you know what, configure this file, copy this file from so-and-so location. Fantastic. Now, the catalog is not going to contain the file content. All that the catalog will ever tell you, or it's just a file, it could be a file or it could be any resources. Okay, it is not just this one. It could be any specific resources back to. So once it goes back into a resource, either I can choose it from a Puppet file server, or from an FTP file server, or from a HTTP file server, or even from a normal your normal network file system to NFS file server, to any one way is supported back here, not just a Puppet file master. And it doesn't have to be only this particular resource. Any kind of resources can be provisioned back to. Be aware that the catalog itself does not contain the content or the file or the resources. All it tells you where it should be found. And once it has found that particular location, just collect it, run it, apply the catalog, and when it's applying the catalog, if it has to fetch a resource from somewhere else, fetch that resource, do that action, and then success, failure, etc. Just send it back to your Puppet report processor, and once it goes to a report processor, do whatever stuff you want with that out here. So typically, all of this in a Puppet master, if you have a Puppet console out here, will typically store it into a Puppet DB if you have set that one up. So it will store it in a database where you can just specify and store all that information out there too. So that's just about how it really works. The agent connects, gets a fax, checks a classification, and having got the classification, gets a catalog, applies a catalog, any resources, picks it up. Having got the compilation of the file at this point, then all it ever does is to just keep sending the report back to the server, and having sent it to the server, that's it. That's all that it does. So the master by itself, all its only job is to say, you are this node, given this node, these are the data, these are the catalog applicable to you. That's all it does. Collect the data, store it, report on it. That's all. It does not do any execution. Any execution is done only on the client or the agent itself. So the agent is the one that really works back here. How the communication works, all of it happens to be on a secure SSL connection. So essentially, the Puppet master basically runs in the background for a master server. So essentially, when we talk of the term daemon, the daemon basically represents exactly a process which runs in the background. It has no console, no nothing. You can still run a master in the foreground too. Okay, that's perfectly fine. And you can run an agent also without the daemon too. So both things are perfectly possible. Now, if this is perfectly fine at this point, okay, all that the Puppet master really does, it has the configurations for different hosts. Okay. Now, typically, the easiest way is, if I have some 10-15 nodes, there's a starting point which most Puppet people make a mistake. They end up writing the configuration for all 15 nodes in one huge file, or maybe 2 files, or 3 files, or 4 files, or 10 files, one file per host. We typically don't do it that way. I mean, that works. That literally works, but that's not one of the most efficient way to do it. All that the master has is just a file thing. This node has to be configured in this way. That's it. Okay, so that's all it has, that information. The agent is the one which basically talks to the master, and all the talk happens via a secure SSL communication. That's it. Now, the first time when they have to do it, they have to, both the slave and the master have to do a kind of a handshake to establish and exchange keys between each other. So essentially, the slave will send its key back to the master, and the master will decide, and here is the important point. When a key comes from the host, if the master chooses not to accept the key, nothing will ever get run on host. By default, nothing will ever get. You can also set up auto signing. Auto signing is whenever a new host gets added up, all that the host will do is automatically send its key to the master. And when it sends a key to the master, all that the master will do is it can decide, do I want to take the key? Do I not want to accept the key? If it chooses not to accept the key, so machine 1 or host 1, host 2, host 3 will never ever be able to communicate back to the master. They'll be continuously sending the key back. The master will simply say, look, I don't want to even bother. I don't want to help you. I'm not going to even talk to you. So the first step that actually happens out here is the key communication. And once the key communication is actually set up, then all the communication really happens back here. So coming back, just slight things. So typically, this is just how the agent really starts sending back. This is something that we talked about in the earlier way. So all your catalog informations are basically stored either in your database, Puppet database, and all your code basically comes back under your manifest. Manifests are basically files with a .pp extension. Okay. Now, don't ask me why it's called .pp, but it's just called .pp, and that's where all the configuration is basically done. Once the manifests are done, then it gets parsed, it gets compiled back out of here. Ultimately, the server and the things basically work only by a two-way certificate communication. So the certificate has to be exchanged back. So when the agent communicates, it sends out a certificate, and the certificate is accepted and signed on the master. So the master has to do a signing. By default, auto signing is totally turned off in Puppet. We do not recommend you to enable auto signing unless you choose to say, okay, all certificates we know will come only from so and so location, so we trust those signatures, in which case you turn on auto signing. But typically we do not enable auto signing out here. And so once it is either auto signed or manually signed and accepted, then the signed certificate gets available back to the agent. So the agent and master are now basically able to share handshake. They got a communication back here. Now, once that happens, and this is a very, very, very important one, a catalog is sent, the compiled, parsed one, whatever, a catalog gets sent to the particular agent saying that this is what has to be done. You don't need to worry about what a transaction evaluator is, but essentially it just says like, okay, should it be done? Should it not be executed? Should it be run? Should this code be done, executed? Yes, no. And once it is done, there is something called a Ruby abstraction, a runtime abstraction layer, or RAL. So essentially what the RAL really does, and this is very, very important. Now, imagine what you would write in your code. In the olden days, when you were writing the code, you would have to write code like this. If platform equals to Ubuntu, run apt get Apache 2. I wanted to install Apache 2. Fantastic. If platform equals to Red Hat or Debian, then run yum get install HTTPD. If the platform happened to be Windows, then install and run Apache 2.httpd.msi. Whatever is the case may be. If it is macOS, do this. If it is so ultimately, just to install your code of Apache, just for 4 things. You have to write code like if platform equals to Ubuntu, if platform equals to there, blah, blah, blah. And in the case of defaults, you do nothing. So you have to write all that code yourself. Now, typically in Puppet, this is abstracted away from you. All you have to do is you have to say install Apache 2. That's all. You don't have to worry about whether it's called Apache 2 in Ubuntu. You don't have to worry if it's called HTTPD in Debian. You don't have to worry if it's called httpd.msi in Windows. You don't have to worry about all those things. Why should you worry about it? Instead, all you would just say, install Apache, and leave it at that point, because ultimately that code which is getting done out here, that specific code or the command to be run on the platform. And this is where, how do we know the platform information? We got that information via factor. That information via factor, which is run in the background, which we are not aware of here, but it gets run in the background. And because it gets run in the background, you got the platform, your RAL is able to execute the specific platform dependent code. You don't write platform dependent code. Now you can imagine where the benefit of Puppet really starts coming in back. You mean to say I don't have to run an apt-get yum install? Nah, don't even bother. The same recipe will work just fine for you, whether it's running on this or this or this. It should run fine. That magic is taken care of for you by RAL out here. Finally, generates a report, and having generated the report, send that report back to your master. This is the flow that we talked about. I say here, take the code and send it back here. If it required any particular file, for example, a resource, etc., you do have a specific thing, okay? And the default port for REST handler is an agent can also talk to it. This is not explicitly mentioned or very clearly done. Client can also communicate back to the master, not just via SSL or not just via anything. It can do a REST call. So there are certain REST APIs which are exposed. So I'm not getting into what is a REST versus SOAP kind of a web service. Just think of it as a service that the master provides for the clients. So you can just use it over plain HTTP itself, so on or HTTPS typically, or it will be on HTTPS. So on HTTPS also the certificate gets passed, the particular parameter gets called, the service gets called. Think for example, do this, do that, and essentially or it executes certain commands. So you have REST API also which is running. You do have a file server too. As we said, if you want to, you can use a file server or Puppet server. Otherwise, if you choose not to use a Puppet or file server, fair enough, you can have it from any other file server too. You can say, get it from a HTTP source, get it from a FTP source. But typically, yes, we do use a Puppet file server too. So that's something that we do back here. The configuration, as we said, this is just yet another repeat and a rehash of what we are talking about here. And at this point, when we're talking about the rehash here, when we're talking about the master, essentially the agent has to send a request for catalog only provided that the certificate has been accepted and signed. If it is not, always the agent will say, I don't have a valid certificate, so I'll keep sending its certificate back to the master for connection. And if the master chooses not to accept it, not going to happen. Now, all that the master ever does is to build the configuration, make it available, and then say, and send it back and say, this is the information. The agent pulls it back, the catalog information, and once it has got the catalog information, run the steps back here, apply it, done, done, done. That's it. That's all the simplest Puppet is all about. This is a whole lot of theory to be covered in quite some time. But yes, in essence, this is it. This is a core point of a Puppet. Puppet also comes with a whole bunch of its own terminologies which are there. Typically, the core components which will be saying, and this, the understanding of these terminologies is going to help you write better Puppet code. What we have are called as resources. Resources is basically something that consists of main resource declarations, and essentially you can just specify, typically most of the code consists of resource declarations. An example, very, very simple example of a resource. Well, as you can say, user. A user is a resource. A file is a resource. A group is a resource. Anything that, or maybe a directory. You want a directory to be created. A directory is a resource. Fantastic. And a directory has so many files. So you would like to say that this thing has to be done. So essentially, a resource basically says, certain actor, something about the system. For example, should a file exist? Should a user exist? What should be the permission of the user? What should be the user name? What should be the user ID? What should be the group ID? So typically, this is something that you can just say, the typical one will start by saying resource type, which is any type that you want to, a resource name, which is enclosed in a single quotes, followed by one or more attribute values. Here is a gory example of how you want to put a resource. For example, as you can see out here, we are just saying, first of all, that there is exactly one user called Michelle. Now, secondly, this will come back to what ensure present means, but in essence, it says make sure, okay, that this user called Michelle exists in the system. All right. Make sure that his user ID is set to 1000. His group ID belongs to 1000. Make sure that his shell is set to /bin/bash. Make sure that his home directory is set to /home/mission. You can specify wherever you want to do. So tomorrow, if you wanted another user to be created, fantastic. You can just say user Sridhar, followed by whatever attributes that you want to do there. By default, Puppet has a whole bunch of resources available to it. If you want to see the whole set of things, one is either go to the documentation and see those documentation on what are the things, or better still, go to the command prompt, and once you've gone into the command prompt, just type Puppet resource minus types. That will give you a complete list of all the features and all the types which are available for you in that specific for what Puppet knows about. You are free to create your own resources. So you can have default resource type. You can create new resources type if you want to, but we typically define them and classes, not resources. There's a difference out there, but yes. So if you wanted to see that, you strongly suggest go to command prompt, type in puppet resource minus types, and you should be able to see all the default types which are there. The remaining sections on what are resources, what is the resource containment, how do you define, and what is an ensure present. In the last section we said ensure present. So what is it? What does ensure present means? What are how do you define relationship between various resources? How do you make sure that one has to be done before something else or be before something else? So all that we'll be talking about in the next session when we talk about resource in greater detail. Manifests, on the other hand, are essentially the core programs, okay, like literally by default, okay, if you are going to set up Puppet, okay, if you create a manifest called site.pp, that is taken up as a basic default manifest for you to run for it. You can have any kind of a manifest, but typically the site.pp typically starts and says this is the starting point for all. You can include other manifests too. Not a problem. You can include X, you can Y, you can do anything out here. So the site.pp is a starting point which basically covers everything which are there for that specific thing. So all the code, all the things, any code that you want, how you want to do that, etc. All your Puppet code really gets into your manifest. You can have more than one manifest, and managing manifest itself then becomes the challenging point of everything. By default, they all use a .pp example, and it's typically found under the manifest folder of etc Puppet or Puppet Labs. Again, as we said, all folders here refer to the open source versions. On the enterprise edition version, wherever you see /etc/Puppet, just refer it to etc/Puppet Labs. Very big deal. Okay. Basically, there's no other greater difference behind that. So sometimes where you see the Puppet Labs and you find it's not there in the documentation, just make sure it will be under etc Puppet. So just be aware of that one small difference back there. Now, manifest, we'll be looking into code when we see how all the code is done here. And we also have classes. So now, class are basically, we write code within code block in classes. Now, you do not have to use classes. Okay, and let me put it that way. You don't have to do it, but we strongly recommend that you create classes. Use classes for it, because it makes reading manifests much easier to maintain rather than writing every single thing back out of here. There are a lot of benefits of using classes, but essentially these are the code. So whatever we talk about the code, we said manifest contains code, and the code itself is contained within a class itself. So for example, you can just write, okay, a class by itself. So you can call a class by any name as long as it makes some logical sense to you and has meaning to you and your organization, and people can understand what the class is. Not a problem. But you can feel free to call it by any name that you want to. And this is a problem of an unusual source of issue with most people coming to think. There are two parts. If you see in the previous slide, there's something we call as a class definition. And secondly, we have what is a class declaration. Now, a class definition by itself does not execute any code. Okay. Now, essentially, a class definition basically says this is what the class should be. These are the attributes. These are the values, etc., etc., and these are the steps to be done. And that's all it does. But it does not actually start executing the code. On the other hand, okay, a class declaration. Okay. Now, a class declaration tells Puppet, you know what? There is code within that class. Evaluate and execute the code within that class. A class declaration is the place where code execution actually happens. Be very careful about what happens out here, okay? I'll just give you back. Let me revert back to the previous slide. Can you see this definition called class example underscore class? Wow, we have a class. Now, Notice how this example class is not quoted in single quotes. Just be aware of what we are doing out here. Can you see what's happening? We are specifying the class, we are specifying the class name, and within the curly braces, whatever stuff we want to do, we do that. But we are not actually executing any code here. All it tells us that here is code that needs to be done. Now look at the second example out here. Now the second one is the preferred way. If you look at it, we have a class. Now notice we are not putting any class name. Can you see what we are doing out here? We are not putting a class name. We are putting the class keyword and a curly braces, and we are mentioning the name of our class within single quotes. So we are saying execute all the code which belongs to example class here. Now, can you imagine why the classes become important? Classes now become important because in another manifest, I can actually have it run twice. I can have this evaluated once, I can have it evaluated twice. A declaration, I can say declare it again, declare it yet again, run it the same code over and over and over again. I don't have to do this multiple one time. Whereas if I had written without a class, whatever code was there in this one, I actually had to reproduce it once, then down the line again reproduce it once. So you can see how the code management becomes very harder to be done. There are two ways of declaring this particular one. One is a normal class declaration. When we say include a particular class name, see the two syntax difference between Puppet. So here within Puppet itself, you can see how the declaration kind of varies. But we'll be getting this into detail. But in essence, just be aware the include and the resource type declaration are two different ways of doing the same thing, except that in later versions of Puppet, we prefer to use the resource-like declarations. We prefer, it's recommended not to use a normal class, but instead do. There are cases when you may have to use an include portion, then appropriate where it's relevant, we will point it out to you during the hands-on session too. Now, okay, so we have got resources, we have got manifest, we have managed to organize a code within classes. Now what we do out here is, hey, you know what? We can also start grouping our code together, not just in class, but inside modules. So when we talk of modules, modules are basically a collection of manifest and data, even facts, files, even templates, okay? They do have a very, very specific directory structure we'll be covering when we talk about the module section. But in essence, what you can do is you can organize your modules into, typically, very rarely would you find that you will have to write exactly one class. You may end up having 3 classes, 4 classes, 5 classes. How do you make sure that they are treated as one logical whole? Now, typically, to treat them as one logical whole, we introduce a concept of modules. And essentially, when you do that in modules, you can have multiple classes, you can have multiple manifests, and typically, this is one of the best practices of Puppet. Puppet will simply say, if you have to write code, create a module. Do not write it in free format. You can still write a free format. Like we said, all you have to do is put a manifest. You don't even have to write a class. Hey, just put the whole code in manifest. Simple, no issues. But to avoid that problem, to manage it down the line, we strongly recommend that you use a module. So we'll be looking at modules also when we see that in future sections, in the hands-on sections. So we'll talk about modules and see how modules also work out too. The full set of glossary that you are looking back out here is way beyond the scope of this session. Okay, so essentially we have a class which we talked about, we have a data type which we'll be seeing when we talk about this one, then we have a defined resource which is the resource part of a resource. We have environments which is by default production, but yet we have dev, QA things. Then we have an exported resource which is basically a resource which can be used by anything else. Factor, the tool which is there, a whole bunch of terminology out here. Master would typically mean the master node itself, which is there. Then we have manifest, which you are seeing out here. We do have inheritance, which basically means you can reuse code, so you don't have to keep rewriting all the code back and forth. A classical example of inheritance would be when you create a generic web server, and from a web server, you say Apache web server and an Nginx web server. Come on. We can have two classes like that. So they share common properties. So as far as the common properties are there, they can be put into a base class, inherited back out here. Then we also have various set of properties. We have the providers, we have resource declarations, we have roles, which we'll be talking about when we talk about in module 4, when we talk about the designs, when we talk about environments, roles, why we need environments, why we need roles, and typically we can have a subclass, which is basically when you talk about inheritance, etc. And that's it. So these are the whole bunch, and it's just part of the terminology too. Some of which will be covered. Typically, we'll be talking about scope, and we'll see in the scope also what is to be changed, what is not to be changed. So we'll look in all that portion over there. Now, without further ado, we will get into the hands-on session where all we are going to show you is how to set up the master and how we are going to set up the client too, and how to establish a connection between the master and the client. And once we have established a connection between the master and the client, we should be good to go, and we'll show you how the communication really happens back here. Briefly, we'll also show you the small wrinkles around doing the installation. For our demonstration session, we will be looking at doing this on Ubuntu 14.04. The instructions are also shared with you as part of the LMS, so they are given as a notes in documentation, so you should be able to follow this. But in essence, the same instructions can be applied to any operating system. Just be aware that during the master installation, we will not be installing the master. We cannot install a master on Windows servers. That's about it. We can install a master just about on any Unix system. The clients can be installed just about anywhere else. Okay, so with that information available, let's go further and see how this is actually being done out here. So in our case, okay, let's just go back to my portion. Now what I'm going to do is, as we said, we already have a box, so let me just run back here. Just give me a second. Okay, there we go. Fantastic. So we are going to connect to, so let's just say a box called Puppet Master. So we have this already set up. This setup is already done via Vagrant. So we do have VirtualBox and Vagrant, and the installation on how to set up Vagrant or how to set up Vagrant is beyond the scope of it. The materials and instructions for how to set up Vagrant and VirtualBox are already covered in existing DevOps courses for Edureka, where we have explicit instructions on how to set up VirtualBox. So this is basically a VirtualBox machine. So on our case, we are going to establish this on VirtualBox, two VirtualBoxes. One is called Puppet Master, one is called Throwaway. We just want to show that as a throwaway machine before we actually get into other boxes too. Now, the first thing that you do out here, okay, I'm just going back as a root, so I just want every things to be done. Now, pay very, if you look at this, okay, so you should see by default, okay, you will see on Ubuntu 14.04, Puppet is already installed. The client is already installed. Now this is not what we want. Okay, the versions which come back with 14, this is a pretty old version. Can you see that version as 3.4.3? So here, let me just look. -n1, and you should see the Puppet version coming at version 3.4.3. The client by default is already installed on Ubuntu 14 machines. It's not something that we prefer to do this. Okay, we want to install the master.
first. So to install the master first, there are two things that we need to do. First, we need to purge the agent, the client version altogether from the master. Now, typically on some boxes, your client may not be installed. So this step that you're seeing out here is not necessarily relevant for you. You may not even want to see this. On some boxes, you may not even have Puppet client installed. Your Windows client, okay, for example, on let's say on Solaris, you probably may not have Puppet installed by default. So that's great. Ubuntu does it. So to do that, what we do is we set apt get, and this is a standard portion. We can say just and do this one. All right. Now, once this is installed, the -y option is to basically say, hey, you know what? This is the command we do. All we are saying is purge Puppet and Puppet common. The -y option just to say, you know what? Let's just forget it. Okay, let's don't ask me for anything. In our case, it's perfectly fine. And since I have extra code also, I would say apt get auto remove -y. Okay, because I want to remove all those unwanted packages. So that, okay, remove this too. Great. So now, all of which has been done, taken off, and you should see this, everything which is required gone off. Now, have we purged Puppet yet? Unfortunately, if you look at it, you will still see this folder. Okay, if you see that this is gone, great. Everything is done. Fantastic. Lovely. You should also see this under ls-al/var/lib/puppet. These are the two folders that you will see. Now, can you see this here? Hey, nothing, all gone. Beautiful. So everything has been happily taken off. So there's nothing left for Puppet to be installed. Okay, so my Puppet is at this point clean. And when we say about clean, what we need to do, and here is the same thing out here. As we said in Ubuntu, it's available by default. Kick it out. We don't ever want to do this. Now, we can't just do apt get install Puppet Master as we see here. We cannot do this yet because the first thing that we need to do is to add the latest updates on our machines. Okay, so here are the full thing that you need to do out here. You can get, there is a very specific version naming for it. Typically, you should be able to get on Yum systems, you will typically be able to get like this. You will see Puppet Labs release the collection of operating system version noarch.rpm. So for CentOS 7, this will become yum.puppetlabs.com/el/7/products, etc. And you can see this things coming back here. For Ubuntu, you need to get the deb package, which is wget, and this is a command that you use. Again, those documents are all shared with you, so you should be able to see that, but just add it. And, oh, sorry. CD, pwd. All right. Paste, and all right. So if you have got it connected, you should see this file being created called .deb. Beautiful. All right. Puppet Labs release trusty.deb. Now, once you have got this, then all you need to do at that point is two things. Paste it back, add this package here. See that, yes, this is done. And very importantly, whether you're doing this on CentOS or RGL or Ubuntu, make sure that your repositories get added. So update your list of repositories. This is true even for Salt. This is true for Ansible. This is true for Chef. This is true for Puppet also. Okay. Make sure that your repositories get updated back. Fantastic. Now, if everything has been done at this point, okay, now what you should see at the over here is that all the packages gets installed, gets your downloading, blah, blah, blah. And once you have done that installation, let's just wait for this to be installed. All you need to do is then just say install Puppet Master or any other tool. If you wanted the client also to be installed at the same time, then install Puppet Master and Puppet, which we typically don't do out here. So let's just wait for, there we go, and paste it. And if you have done this one with the -y option to say just answer yes to all the questions, and you will see that it starts picking up. Now, because you have that portion, you can see that, hey, you know what? It's getting the Ruby code, it's getting things, it's unpacking all the stuff, and it will start your Puppet Master too. Oh, there we go. Now, if you wanted a client also should be done. Great. Now, if you have this to be started, we are not yet ready for our Puppet Master to be set. We are not yet ready. In the meantime, what we have done, we have kind of skipped one very, very important step. Now, whether you're doing Puppet, whether you're doing Ansible, whether you're doing Chef, whether you're doing Salt, be very, very, very careful that before you did all of these steps that we have done so far, be sure that you have set your host name correctly. All right. So if you look at it, hey, you know what? We have it as puppetmaster.sridemo.com. Beautiful. Brilliant. Now, you can also look at what's happening here. If everything worked out fine, you should see Puppet. There you go. You see the file which has been created back here. So you can see etc puppet has been created. And if you also look at it, you should see var/lib/puppet. And if you look under var/lib/puppet, that has also been created, you should see a folder called SSL. Can you see this SSL being set up here? Great. Now you have two ways. Now, by default, if everything was set up correctly, you don't have to make any other change. You should be good to go. But we'll see the two changes which we need to do for doing this. What we are going to do is, we are going to do remove this SSL directory. First of all, before removing this, we will say service puppet master stop. We need to set our certificates up right the first time around. So we'll say stop this Puppet Master. Great. You want to start it, service Puppet Master start. Not a very big deal. So we have done it so far. Great. All beautifully done. At this point, what we have done, and be very clear, we have just created a Puppet Master. We have by default it starts. You're not expected to start it right now because we need to do a little bit of change with the file called puppet.conf, especially with the SSL certificates. So what we are going to do is we want to kind of take a backup. So let's just say, let's go here, move. I'll just take a backup here of var/lib/puppet/SSL to /var/lib/puppet/SSL back. Let me just take a backup of this. Great. So if I take there we go. I should have a SSL back just in case something goes wrong. You can always bring it back to. At this point, what we have done is we have set up a Puppet Master. We have stopped the service. We have taken a backup of a SSL folder. Mainly, why we want to take a backup of a SSL folder is Just in case something goes wrong, we have something to revert back to. Now, having done this, before we start a service master, so Puppet Master, we are going to edit this file called etc puppet and puppet.conf. Now, you should see two sections here called main and master. So the first one, the main, which basically tells you where your log files are going to be found, where your variable directories are going to be found, where your SSL directory is going to be found. And that's a directory that we took a backup just in case for here. By default, it will also create, have this one line called template div. This is not going to be, it is not supported anymore. We typically do not use template div any further. So typically what we do is, even though by default this line is enabled, we just edit and comment out this line. Any line beginning with a hash mark in the configuration file is a comment, will be ignored back here. Leave all of those lines. So let's just keep every single line back here. The only change that we are going to do is going to change this back. Now what we also want to do is, we also want to say, hey, you know what? We are going to recreate our SSL directories back here with a different name of a certificate names. Now, by default, unfortunately, okay, if you want to have this integrated with Apache Passenger, which we are not covering back, but in case you ever wanted to integrate that with Apache, just be aware, Salt has a bad habit of assuming that the server is called Salt. Similarly, Puppet has a bad habit of assuming that the server is called, the Puppet master is called Puppet. So what we typically do is, we can just say, here, my cert is called Puppet. Great. Now, having done this Puppet here, what you also need to specify here are what are the alternatives named for this. So we can just say, here, my Puppet, it's either the certificate name is called Puppet, or it's called Puppet Master, or it's called Puppet master.3demo.com, which happens to be what I call as a fully qualified domain name, or FQDN, for that particular server. Now, all of this has been done. Great. Save the file. So let's just say, save this file. And once the file has been saved out here, just say restart your service by saying Puppet master start. And once this has been started, if everything went out fine, you should also be able to see your entire thing. So let's just look at the folder called var lib puppet, and you should see that your SSL create file has been recreated back here with the names that you have chosen. Now, if this has been created back here, okay, you should be able to use a command called puppet cert, and the puppet cert command is basically used to list all the certificates which are available for the master. This is being run on the master only. So the minus all says all the keys which are available accepted out here. So certain list with a minus all option. So you can see this. Can you see this line coming back here saying that, you know what, a certificate, can you see this plus sign against things out here? So which means that there is one certificate, okay, and this one certificate belongs to puppetmaster.3demo.com. The alternative names are Puppet, Puppet Master, puppetmaster.sridemo.com. So either which way you want to specify, I should be able to get that certificate. And the plus sign on this means that this certificate, of course, the master has to accept its own certificate. So all it means is that the master has accepted its own certificate. Good. So there is not going to be any issues. If you don't specify the minus all commands out here, it says there are no certificates pending for acceptance. Now, all this says is, this shows me all the certificates which have been accepted, not accepted, everything which are there will be shown. A plus mark at the front indicates that yes, this certificate has been accepted. Now, if you have come to this point, you have established your Puppet Master. Okay, let's redo this just for things. The first thing, let's start by saying, hey, you know what? We are going to uninstall Puppet Master completely, re-establish back from scratch. Ouch, ouch, ouch. Now, to remove your Puppet Master, apt get purge Puppet Master Puppet common and -5. Say, I want to remove this package altogether. Let's do a reinstallation. So for some reason, you want to reinstall your server pack. Let's go ahead and do a certain things. So once you have deleted this portion, okay, you will see very importantly, if you pay very close attention to things, you will see that there are two folders called var run puppet and var lib puppet. You will find that these are not going to get removed off completely for you. So to purge it completely, there are two things that you need to do out here. You first of all need to do a remove, auto remove, make sure that all the things are being done. Great, finished. Everything has been done. You need to remove those two directories, var lib puppet, var run puppet, and also etc puppet also. So what we do is rm minus rf, which means remove this recursively with the force, the folder called etc puppet. If you want to take a backup, take a backup. That's up to you. Frankly, we don't. I mean, if you're going to reinstall it, there's no need to take a backup unless you are pretending want something else. So, done. We have removed one folder. Similar manner, remove this folder under var run, remove this puppet. Take two. Great. And within var lib puppet, remove this. You're done. So now you should have this as a clean thing. There's nothing out here. So if you were to type puppet help, it should say no such file or directory. Great. So it's all been taken off. Beautiful. So great. So now we have to reinstall a Puppet Master 2. So now to reinstall, we already have a deeper package. Everything has been done. So package has already been set up via this wget dpackage apt-get install. So all I need to do at this point, I don't need to do an update, etc. I just have to say, since the package is already installed, install Puppet Master. And once it's done, that's it. Okay, go ahead. Now, my Puppet Master has been started, installed, and you should find this just running fine too. Now, by default, if you look, you should see Puppet Cert list, which is what are all my certificates which are available. You should see this out here. Can you see this one? Can you see this line thing? Setting template dir is deprecated. And here you can see that, hey, you know what? I already have a certificate to be done. Now, if I wanted to remove the certificate, if I wanted to say, hey, you know what? I want to recreate these certificates back from scratch. I can do a lot of things, including I can just say if I want to purge a specific client. Okay, let's just see here. If I wanted to, okay, let's just see. All right. So let me just go back here. Let's see. Paste. I can do a clean. I say I want to revoke the certificate. I want to do it from scratch. I can do puppet here. master.demo.com, and there you go. Can you see that? This has removed that specific file altogether. It has revoked the certificate. Now, if I were to do the same list, I could say, hey, there, even the certificate service is not recognizing itself. So the master itself does not have a self-signed certificate anymore, which we know, we are perfectly fine. We want to create it from scratch. So what we do is, to stop that, first of all, we stop our Puppet Master, stop it. We don't want to do it. Then we also want to remove our SSL folder, okay? Because we want to recreate the certificate back from scratch. So what we do is rm minus rf /var/lib/puppet/SSL. Only the SSL folder now. Having removed this, great. Done. We are not going to create any more things back here. Then edit our etc/puppet/puppet.conf. We are still on the master. Just make sure, shut this one up. If I wanted to, and this is where we said, if I wanted to, just call the cert equals to puppet, and also say alt DNS underscore names equals to puppet master. Any alias that you want to give for this, puppet master.3demo.com. That's done. And call save it. And once we have saved this file, just start our service back again. And if our service went back signed correctly, if a master worked up just fine back here, you would see that it takes a little longer to create and start it the first time round. You should see my certificate has automatically been created. Puppet cert list minus all, and you should see that this has been created. And hey, you know what? The creation has happened and it has been accepted. So in other words, my master is now fully configured with the certificate. Okay. Now, while you're looking at the master which has been created, so you should be able to see the file called var lib puppet ssl, and there we go. You have your private keys, public keys, CA certificate request, search, etc. all have been created and just being done. Fine. We are good to go, at least in the master. The master has self-signed. Great to good to go. Under the etc puppet, all your things are going to be under the etc puppet here. So typically, if you look at this one, you will see a set of files which are available. Okay, one is called your auth.conf. We'll be looking at what these files are. Essentially, this auth.conf tells you who can have what access to which folder. So here you can say who gets what access where. So every single things are there out here. Typically what happens is, if the file does not exist, okay, in Puppet, you might, it just says who has access to access what part of Puppet. That's it. We also have your file server.com on file, and this essentially specifies which directory, where, etc., who gets access to what out here. You should have an allow, where you say allow star line, which basically says that give them any file server, anybody should be able to read that particular file. That's about it. So if you want to add more files over here, make Puppet use work as a file server, just add this particular one. For example, like this, like so. And see the slides which have been done? Now, if you have given this as extra files, then any file can now, if I were to keep a file under etc puppet/files, okay, then all of that can now be referred to as puppet ://x.jar. That's it. Essentially, it'll be called extra like this. So you can just say here, under the server, which is the current directory, there is a folder called extra files, and under the extra files here, this is where I have my file. So I can put an x.jar under here. That will be referred to as extra files/x.jar. This is the standard way of creating a file server. So typically we don't create this one, but if you want to restart it, and there we go. So that's not to be a problem out here. Multiple ways you can do this, and the allow star basically gives everyone full access to the file server. So here we can just see how the files will be accessed. So note this directory etc puppet files. Under etc puppet files, in tomorrow's session when we're talking about creating the resources, etc., we will be creating the files out here and placing the files and configuring it based off on that particular post. So we are just saving it at this point. Great. We are done. So our machine, our Puppet client is perfectly fine. Our Puppet master is working fine. So if you look at it, we have also kind of upgraded Puppet 2. So if you were to take the tail -1 and is Puppet help, gives you a whole list of help on Puppet. I just want the last one because I know that the last line has a version number. So from 3.4.3, we have upgraded ourselves to Puppet 3.8.7. Beautiful. And we have Puppet Master running back here and version 3.8.7. Now, in a similar manner, okay, let's see what we need to do with getting the client to work. And we'll see how to get the client to communicate and set it back to. Now, when you're doing this, let's just take now. Let me just log into this. Let me just change the property here slightly. So make the foreground. Okay. All right. So the client is in a different color from the master, just for the differentiation purpose. Again be aware, we installed out here as 3.4.3. Beautiful. We don't want to do this. So we want to kind of get rid of this. So we say apt-get purge puppet common. We want to upgrade it ourselves. So we remove it completely. And having removed this completely, we will also get rid of any unwanted packages. So we would say auto remove -y, and there we go. We have done with it. So everything is run out from here, and we should not be able to find a folder called etc puppet. Hopefully we have got this done. Okay, no such file or directory. Great. So we have cleanly uninstalled Puppet out here on an existing Puppet 1. So what we do back here is the same stuff as what we did for all right. All right. Here we go. All right, so let's just do this portion back here. And let me just copy this entire stuff with one go. There are multiple ways. So the same way as we did out here, we need to get our first step is to get our package. So let's go back here to my client, CD, and get this one. Okay. So now I should get this package. Got the package. Great. Having got this package, install it. So go back, and my pasting is, so file has been downloaded, done, has been set up over here. Do an upgrade of the repositories. So let's just do an update of our repositories. And if everything has been working up fine here, great. So it takes some time. So if all the packages downloaded, blah, 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 so it takes some time. So let's just see here. So once this has been done, at this point, the only thing which is required at this point is to install our agent. Now, unlike a server, etc., we don't have to worry about creating our portions. Just be aware, same way as you have set for your master, you also need your client itself also to have a host name. Okay. Now, we are not getting into how to set up. Okay. Let's, here we go. Puppet. So yes, and now we have a Puppet we set up, and if everything has worked out fine so far, we should get to see Puppet 3.8.7 to be set up to here. Now there are two things which are required, okay, out of here. Now what we need to do is, there are two things which are very common. Okay, one, we need to edit this file called etc default/puppet. By default, you would see the start equals to no. Change this to yes, which essentially means that the next time your machine starts, your Puppet client is also going to start automatically. If you don't do this, setting it to no, the agent, every time you will have to create and set up the agent manually on your time. So that's the only thing that is there. So just change the file etc default puppet to yes. And once you have set it to yes, hey, you know what? We have got it running. Okay, next time I shut down, restart this machine, I'm bound to get it. And yes, if you look at, there should be now a folder called etc puppet created. Now you also have a puppet.conf file here also. Now we will edit this file called puppet.conf. Just be aware that this is on the client side. Aha, can you see what's happened here? By default, again, whether you like it or not, even if it's an agent, this was happily set to master, not as an agent. Now what you need to do here, you can just change it, because this is for a client, not for the master. Change that master section to agent. Now, having set the agent out here, you need to specify where the server is going to be. So now my server is going to be puppet master .3demo.com. Can you, just one line I need to add, just make sure two things. One, change the master section to an agent section, and having changed that to an agent section, add one line called server equals. Now this server basically indicates where my master server is going to be located. Wow. All right, at this point. So the client has still not been done. It's still not communicated. Now, why does it not communicate? Because it doesn't know where the server is. So typically, you go back to the file, add the server equals to whatever is a master server, you can have multiple things saying that if this one fails, then go to the next one, etc., etc., which we are not going to. We are just saying just connect to one anyway. And having said that, we are done. Our Puppet are so far the configuration files on our things is perfectly fine. Now, I need this to send its certificate directly rather than waiting for it to start, restart, and restart my machine. I can do this and say agent minus T. Now the command Puppet agent, the Puppet is the main command. Within that you have a subset of agent, etc. So essentially when you say that agent minus P, what this is going to do out here is, hey, you know what? It will say creating a new SSL key for throwaway.3demo.com, and it'll say I cannot find this. Great, and I don't have this for things out here. So it's trying to send it off. Now on the master, okay, if everything had happened back here correctly, you should see, okay, puppet set list, and you should see this one back here. Okay. If one second. Okay, sorry. All right. Let me add one line here. I'm sorry. We do need the connectivity. I thought I had set it up here. My mistake. So 192.168.33.80. Let me just add this one. Master.3. There we go. All right. Okay. Let me try. Yeah, I can get to my Puppet Master. Sorry, I needed to check whether the Puppet Master was set up. So let's just try with the Puppet agent minus T. Okay. Okay. Now you see what's happened. Now it has sent a request back. Unlike the other one, it would have created a request. It could have communicated back to my Puppet Master and have sent that Puppet Master back here saying that, hey, you know what? This is my Puppet Master. Let's go hit this thing. On my master, I should now see, can you see this thing which says throwaway.3demo.com? Now, if you see this out here, this essentially means that I have got and created a thing. So let's just go back here. So there we go. Now you should see this command out here on my master saying throwaway.3demo.com asked me for this connection. There's no plus sign in front of it. Now, because I don't have a plus sign, let me just see if I can do this. Thing throwaway dot demo. Yeah, I do have it. Thank you. So if I wanted to accept it, I would just say sign, and I know my name of the certificate was throwaway.3demo.com. So now I say throwaway.3demo.com, and if I sign this out here, all right, so it has signed this request. So now let's just look at my cert list. There are no pending certificates. Is it actually being accepted and signed? So now I should say, hey, you know what? I have Puppet Master and throwaway.3demo.com. Both have been accepted. Now, the master has sent the signed certificate at this point. So the client now has to accept it back. Say, hey, you know what? Take my Puppet agent minus T. And And you know what has happened out here? It has actually got the certificates, got that one out here, and we do not have any node definitions. We have not yet created any node definitions. Okay, so automatically you can see what has happened, that the certificate from the master has been brought back here. It is signed. Okay, and now it has also tried to get a catalog from the master. In our case, we don't have any catalogs defined yet, but tomorrow if I were to do this, I can just say, you know what, run this. It will still be able to create a catalog and be done. So now between master and throwaway.3demo.com, we have kind of established a connection. So both nodes are now able to sign, be accepted. And because the certificates are accepted, the second time around, whatever was a signed certificate which this one has sent out is automatically picked up. It's able to communicate back to the master and then say, hey, you know what? Do I have a catalog? And you can see the configuration version coming back here. I will say that I cannot. There is really nothing to be done with this at this point. Now, let's do something very, very nice. Okay. Now, what we want to do is we want to start installing certain modules. Okay, then let's see how to write the code. That is something that tomorrow when we are looking at, in the next session we'll be looking at how to create the modules, and on the same machine what we are going to do is we are going to install Apache as well as Tomcat. And we are also going to do something fun. We'll also write our own custom code to do this thing, and then we'll say which is a better way to do things, and we'll show you how it is actually being done. To summarize, what we have done is we have set up a master, we have set up a client. We have given you two hints. One, on Ubuntu box by default, Puppet is already installed. So you might want to uninstall Puppet and get the latest versions of Puppet too. So get always the latest version and install it back. To install Puppet, first of all, always get the RPM or deb package, apply the package, do a repository updates, and having done a repository update, then install whatever is your Puppet, for example, Puppet Master or Puppet Agent. In the case of Puppet Agent, it's just called Puppet, and be done. If everything worked out fine, okay, the uninstall doesn't have to be done. It is required only if it's already installed and you want the latest version. Take it off. If you want to, take a backup. In the case of a master, there are two things that you need to do. You need to stop the master service by default, and having stopped it, remove the SSL folder. That's a key point. And having removed the SSL folder, change your master, the puppet.conf file, and having edited the puppet.conf file, just be sure of adding two things out here. Be sure of commenting out the template dir. This is true whether you do the master or the client. Be sure to comment out this line. And having commented out this line, just make sure that the cert name is called Puppet on master. This is only if you want your backward compatibility back with Apache, because Apache integration with Puppet insists that it is called Puppet, even if though your server is called by some other name. So in which case, if you want to keep it, otherwise the better way, which we do not recommend to do it this way, is to don't let it be as it is. It will just be fine. Just make sure that this template dir is commented out. That's all that is required in modern versions of Puppet. You don't need to do anything else. Okay, that's it. If need be, restart your service and always be aware from a Puppet on things cert list minus all or cert list, which should tell you which certificates have been signed, not signed. You should at least see one. You should at least see one thing, which is about the first time coming in. The master should have self-signed itself. If you have installed your master and you are not able to see your master in the list of valid certificates, out here, which is here at this point. Okay. If you're not able to see a master at this point itself, then one way is the troubleshooting. Stop your Puppet master service, delete the folder called var lib puppet ssl. Take a backup if you want to, delete that folder and restart your service master. Hopefully it should have created it. It should not have done anything greater than that. It should automatically create it. If not, you'll have to look in the log div folder, see what is your log file, and correspondingly take appropriate action, which should not be done. Now, on a client side, all you need to do is, if Puppet is already installed, delete it, reinstall it. Just be aware in here, when you edit this puppet.conf file, okay, because this happens to be, just make sure that your template there is again commented out. This applies whether it's a master or a slave. Same principle applies. Just be sure that this section, which was called master, has no meaning for a client. Okay, this is a client, it's not a master. So typically, just make sure that it is set to agent. Change it to from master to agent. Unfortunately, the installers do it that way, so you have to change it back to agent. And having changed it to agent, make sure that you specify one line called server, and this is the way where you can connect and say, this is my master to where I want to connect to. Okay. Once you have specified, just verify that you can connect. Unfortunately, I didn't connect it by my bad. But yes, all you need to do is you just have to verify that this can be connected back. And if this can be connected back, also make sure if you want this to have do this on default / puppet, just change this one line, start equals to no to start equals to yes. Change that so that next time the machine even restarts, your client basically starts up on its own too. That's it. And if you have set this one up here, then you should be able to say service puppet start. Okay, that's it. Finished. And your puppet agents have started back here. Otherwise, it will just say done. So that's it. So the next time, and periodically, by default, every 30 minutes, your client will now connect. By the default is 30 minutes. Every 30 minutes, your client will now connect back to your master. If there are any changes which are running out here, it will start applying those catalog or whatever configuration that you specified in the master, which we'll see tomorrow. We'll look at it, and all those changes will get slowly applied back. Now, having done that, okay, the first thing from here, you would just say, to complete that one, agent -t. In our case, you can say, hey, you know what, there's nothing has really changed. So nothing has changed, so great, beautiful. That's it. So the first time when you run it, a certificate will go back to the master, and all that the master has to do is to basically see the cert list out here, and if it finds anything out here, just sign by puppet cert sign whatever is the name of your client, which is typically the name of your FQDN, and that's why we say please give fully qualified domain names. Do not use IP addresses. And make sure that they are all on DNS. For example, here, you should see here what we mean by DNS is, if you look in my host file, okay, I do have only the access for 80. I do not know where web01.3demo.com or throwaway.com comes here. But if I were to do a ping throwaway.3demo.com, I should still be able to resolve this. I should still be able to do this. For example, make sure that this DNS is set up for you. We don't get into this one. So let's say dev web 01. This should, if everything is correct, it should try to get to 81. Of course, it's not up here at this point, but yeah, okay, great. It's not up, I don't care. But at least it should resolve the IP address directly, not like the way which we did during the demonstration with, for quick purpose, we went and edited the host file. Avoid that portion. Okay, so that's about it, and that should be how this one really runs back here. The client is exactly the same as we just said. You don't need to do anything back here. As we said, it works exactly by the text. By default, your services are automatically started. As we said, you do have to make the changes back to that agent slightly. You need to touch that agent, make sure that the server, the configuration runs back for fine here. And all you have to do is cert sign. As we said, it's not OPT Puppet Labs. You can just do Puppet. As we said, it depends on if it's the enterprise edition, it's Puppet Labs. If it is the open source version, it is just called Puppet. That's it. There's no Puppet Labs itself here. So that's about things here. Thank you all and have a great day.